Hello and welcome back to another dev episode. I want to continue with my tool from last time, and in the meantime I had some discussions with the guys from Fmodel. So the code I'm importing here is essentially their library they are using in the backend to read all the stuff from Unreal, and so I was more interested to ask if they're okay with that and also if their licenses allow that, because I'm not a lawyer. And so it seems as long as I only keep stuff from Q for parse, I can keep it in my program and they are fine with it. All I have to do is to include them in the credits. And yeah, let's start with that. Let's first get a link to it. So this is a library I'm copying from. Can I just short this? Yep, that is nice. Okay. The about page. So how does it currently look? Okay, so I just made a button. I should probably just make a link here, because I also have a lot of my input from Gildo's new model. Okay. I guess I just make another button. First off, let's save that somewhere. Or maybe it just... Oops, sorry. Let's run it here. Not quite sure if Unity is using pixels here, but we will see in a second. Come on. Okay, great, that didn't work. Oh, now, okay. Yeah, that looks fine. Okay, so we have that. Thanks guys, so your code is helping me a lot. I have to mention this, because I will copy a lot from there. Okay, so what's the basic plan here? We have always, or most of the time, 3 types of files with the same name but different ending. I already worked on the utoc file, that's like the content of where all the files and stuff is stored, as far as I understand. And pack and ucast files that have the actual content that we want to read. I already come on. Yeah, already found out that it's probably using a proprietary compression format called UL. And for that I already looked up another project that is using the original DLL from the game that where this comes from, and wraps it around so I can use it in C#. But maybe I get around it and they just haven't used this compression. We will see. So from their code I can see a whole store is read like, yeah, I read this whole TOC archive that I'm not even done yet to get all the header stuff and what's in them. Hello, website? Ah yeah, this is Visual Studio, never mind. That would be then this file. This is a TOC resource, this is what we did in the last video. And essentially, where did I stop? Add compression blocks. This is where we'll test it. Compression blocks. Okay, and here we can continue. There's a little bit more to read, but after that's done, we just have the TOC file processed, and then we can use the data from there to actually read from the ucast file. I hope. And so on. Anyway, I have to make a new class to just have our TOC resource as a parameter and have the other stuff that we need in it in this class. I could just copy the whole class here, but I don't want everything in here. Also, I want to explore in the hex editor how it actually reads the data. Okay, let's continue. Let's see where we stop. I have a breakpoint here, great. I am attached. And let's load some files. Oh yeah, this breakpoint would hit in every other file. Okay, so now we read one. Which one is it? Global. I do not want global. Yeah, that's the one I'm looking in my hex editor right now. We are at this position. Should be pretty much where I'm currently at. That's exactly where I'm at. Good, and I'm pretty sure we read this compression information string next, as far as I already looked up the code. Compression methods. Oh wait, there was already something in here. Yeah, already. Never mind, the TOC file itself has a header too. TOC class, sorry. So, and this should be something like hex 20 bytes, like this. And that would be, how's it called? I have to move that somewhere else. Compression methods. Yeah, this is an enum. That I also need. Or maybe I should do this before the internal classes. Okay. Okay, so the compression methods. So the default 1.0 they already set, and a possible additional method we now read from the file, which would be this oodle compression. What a weird word. Okay. Well, first let's actually read the buffer. Oh, never mind. Okay, so there could be multiple in here, so you have to add them one by one. Okay, that's one way to do it. So what we want here is essentially reading a subpart of the buffer as a string. So let's do it this way instead. Alright. This is a string. I like typed variables. Continue. Yeah, continue. There could be gaps in there. Ooh, okay, we actually name match it. Nice. I throw exceptions. Okay. And it's a lot of work for just 32 bytes. So let's see what we get. I actually continue here, so it can finish. And breakpoints don't match anymore. You do that, you are done. Copy new in. New breakpoint. Come on, Unity, you have seen that faster before. Always feel free to fast forward on places like these. Come on, Unity, I just added a few lines. Hold on. Keep calm. Ude. Okay, nice, so that worked. Yeah, you can continue. So, okay. So now comes the tricky part. You would think we just continue parsing stuff here. I already can see, like, for example, the length of the string and the actual string in it, which is the mounting, the mount point. But as I already looked up, we just read a big block now. I haven't seen that yet, so... but nah. Directory. That will be true. Where does this come from? Don't I already have that? Read options. Read options, where are you coming from? Yeah, so there are some. This coming from Q for parse. I do not need that. I actually want to read that. Not defined yet? Oh. And this will be there. Almost. Now everybody happy. Yeah, another thing, you always should turn off real-time protection when working with lots of files, because it would slow it down a lot. Why do I always make breakpoints here? Okay. That's quite some bytes. And that would be that many. Boom, that fits perfectly. And it's just a binary blob, this has to be passed out as well. I think the next thing is 33 bytes in size. Yeah, if you get a regular pattern in your hex editor, you guess the item size usually. Okay, so what comes next? Should be actually it afterwards. The meta. Replaced IO chink has oh, if a specific version is found, we have to do something else here. Okay. Let's figure that out. Replaced. So this is the future action. Okay, still need that. I guess we need that too. Okay, I also need that hash. Do I really want this? Yeah, you just become a binary. Yeah, I don't actually care then if this or that. Oh, that was important. Okay, never mind. Actually fill that. Yeah, okay. So let's go back here. Oh yeah, that was about that. Meta entry. Then we need a few of these. Chunk metas. Okay, last stuff here. And that's it. Oops, that's still stuck. See what we get. Oh, it's quite a lot. Well, that looks correct. But that doesn't match up. That's 20, 24, 27. Wait a second. Oh, also, let's do that a few times. Yeah, there are zeros in here, so we are definitely off. Okay, let's figure this out. We definitely start with 20 bytes of hash. That is for sure. Okay. How is this implemented? This is just a byte. Oh wait, what if this is an EO chunk hash? Then it's 32. Okay. But is it? What do we have? This is false. We do not jump. $32 plus 1. Okay. Oh yeah, can't edit here, sorry. Speed is a different topic here. Sure, okay, never mind. In the meantime, I would like to know who actually reads this directory. What is container streams? Ah, okay. Okay. Process index. Okay, that's its own function to read this. This will be used on mount. Mount is when I actually want to load this to memory. Okay, so this happens later then. Never mind. So let me get this straight. We just read the directory here, keep it as a blob, and in the main store file class, whatever, we read this all in, and then find all the files that are connected to it, so all UCAS files, and then by seeds it will find stuff in it, chunk indices. Top resource chunk offset length. It comes from top resource. Wait, we should already have that. Chunk offset length. Offset and length, yeah. Okay, great. This starts to make sense. Another thing, I do not need to throw exceptions. I just return because I later check if this file was valid or not. Okay, this reads the whole top file. Nice. IO store, yes, that actually makes sense. If you have IO store, TOC header and all this shit. Okay, new class. FIO store. Wait, what? What did I just copy? Oh yeah, I copied from the header, never mind, sorry. Okay, so this IO store will contain a TOC resource, which will contain a TOC header. Slightly confusing, but okay. Everybody happy, nice. So now we need to actually load these. Now this is my abstraction, so I can support multiple engines. Okay, so one more abstraction layer. And at some point you want to say is valid here is true. But not so fast. So now we are looking for streams. In my case, these will be just streams. Okay, so if this file doesn't exist, we already have an exception, we don't want that. Otherwise, we want to add it. This could still, for reasons, fail. We still only just want to return. What? I mean, that's interesting, all these string utils. Do I copy these? Aggressive inlining. Okay, let's take part of them. Like every project, this also has a helper class. Just like that. How does it know that it belongs to class string? Ah, because of this. Ah, nice. Okay. So now we should have all the container files as well. You can already see at this speed this will have a part 3 at least. How is this just to read a file system? Finally. Yeah, if you forget to put breakpoints. Okay. Oh yeah, actually we should come to a breakpoint. Because it just iterates all the files in the directory. I need a breakpoint somewhere when it actually is at least a TOC file. What file is it anyway? Global. Okay, never mind. Great. And that's all. One container stream. Okay, cool. Yeah. Finish failing it. Okay. Once we have these, do I know the length of them? I can figure them out. How is this used? What? Ah, okay, this is the total length. If you don't have a ucars file, it's just the TOC file itself. Wait, is that the case for global? Ucars, utoc. There's just no peg file. Okay, I don't see why I need this for now. So let's skip it. Container streams. Okay. Okay, so it's part of this store now. Never mind. Okay, what are you? Wait, what? Never mind, I renamed them. Let's see what that brings. As far as I see, we are done with reading stuff. Now it's just this mounting part. Okay. Come on. Oh yeah, breakpoints. Also, we never get here anyway. This is processing it all now. Okay. So, reading in was already done. Okay, except would have thought this takes longer. This will be fun. Okay, this is where all this starts. Yeah, mount point, where does that come from? That's something I definitely need. That was the first thing in the directory index, so just as a reminder. Okay, so this was a compression string, and this was the first, this is the start of the directory index, and this is the mount point. It's 8 bytes long, that is from here to here, and it's just literally these dots. Okay, but that will be done on process index. Okay, we need which we call here. Oops. Then we need this. Which will be called here. Yeah, and I probably need that too. Okay, so what's the container here? Okay, something for another problem, for another time. Read container header. And as this is definitely UE5, I have to call it here. Okay. So I see this would be a good point to stop here and cut off for the next part. We'll fill that out, and then at some point we hopefully can see actual files in here. Well, let me demonstrate that with Unreal Engine 4 game. We have, for example, PUBG Lite, I don't know, latest, no. Okay, select this folder, it's PUBG Lite, and there is your content. So something like this I want for Unreal Engine 5. Pooh. Okay, thank you for watching if you're still here and haven't fallen asleep. And hopefully you can learn something from it. I mean, I just copy stuff, but in the end you can follow through with me how these files are actually structured and how to get something from them to get to this. I mean, just numbers, actual file system. I'm really looking forward how this will look like. Well, have a nice day, evening, and see you next time.